Hello friends, good morning and welcome to the yet another video session for the subject Multimedia Communication Technique. So far we have seen first 5 chapters, out of which for first 4 chapters which we have already covered in the class. So we took the revision of all those first 4 chapters. Then we have covered chapter number 5 thoroughly through almost 8 video sessions, and now let us proceed with unit number 6. Now the title of this unit is Multimedia Data Compression. Now before we proceed towards the content, let us quickly revise what we have seen so far now. So as far as the contents of the subjects are concerned, so in first session we have covered about what is the analog television system, how it works, followed by the digital television system, followed by the different standards for analog television. Then we have seen the different types of recording for audio as well as video. In that we have seen several systems right from CD, DVD. Along with that we have seen some advanced television systems. And then in chapter number 5 we have seen a lot about what multimedia is, what are the applications needs of the multimedia, followed by hypermedia, the difference between the two. And then we have covered the different data representations, the way the image has been formatted, the different format for the images, and we have seen the more and more details about the multimedia. Now one of the key area that we need to discuss about multimedia is the multimedia data compression, because basically whenever we say multimedia, that means several different types of medias will be combined together. Here multimedia, as we have seen, will be the combination of the image, text, graphics, video, audio. So all will be combined together. So each media will have its own data representations, and then the every media will keep on dumping their own data into the multimedia platform. So because of which the huge amount of piles of data will be available on a multimedia platform, and whenever we tend to stream this particular data after the processing, or even during the process also, we need to deal with this kind of huge amount of data. And that is the reason why one of the very key area for multimedia, like whenever we say that we need to study multimedia systems, then along with the entire multimedia system, its feature, its application, all insights about the multimedia will not be finished until unless we study what are the ways by which we go for multimedia data compression. So data compression, or even we can say only compression, is very important as far as the multimedia communication or multimedia applications is concerned, because multimedia is like huge piles of data available on that particular platform. So let us quickly go through what will be there inside the contents of this particular chapter. So the contents here will be the lossless compression algorithm, so introduction of lossless compression, followed by its different types, like we have to learn run length coding, followed by variable length coding, followed by arithmetic coding. So all these three are the basically the coding types for the lossless image, the lossless compression algorithms which are being used for the multimedia platform. Then we will cover the lossless image compression. So based on or with the help of these algorithms that we are going to study, so with the help of those algorithms there will be the compression achieved. And before we move towards the video compression, we'll study the image compression first. So we will start ahead with first, that is lossless image compression, and then we'll go ahead with the lossy compression algorithms, in which we'll study only the introductory part. Then the finally we'll be covering the basic video compression techniques, in which H.261 and H.263 are there. So this is what the overall the contents of the syllabus that we will be covering. So quickly summarize this. Basically two kinds of algorithms that we will be seeing, that is lossless compression algorithm and lossy compression algorithm, followed by its different types. Then there will be lossless image compression, followed by the video compression as well. Now before we proceed towards the contents, that is nothing but the lossless image or lossless algorithms, let us try to understand what is data compression and why do we require this. So as I told you earlier, on multimedia platform there will be variety of medias will be contributing for multimedia application to get built, and then it need to be streamed as well. Now whenever we say that multiple amount of medias will be bring on a common platform, obviously the multimedia platform will be a digital platform. So whenever the signal are available, like image if we talk about specifically, or audio if we talk, or video if we talk, if those values, if those are directly available, like for example video you can get directly from the digital television, digital video camera, but whenever we say audio signal is there, that we need to that will be available for us in analog domain only, and then we need to convert it into digital one. So there will be certain level of conversion of signal into the digital one, and then when they are brought on the platform, multimedia platform, we have to ensure that the strength of these signals will be very very good. Like for example, when we talk about several images to be imbibed into a multimedia platform, or certain video need to be taken into consideration for multimedia application, then the resolution got to be good, because whenever we will be dealing with that particular data, then the resolution of specific data has to be very very good. And whenever we say resolution is good, that means the sampling and quantization level has to be good. And whenever sampling and quantization levels will be high, obviously there will be piles of data, there will be huge amount of data required to represent the information. And that is the reason why we need multimedia platform with better resolution. So we need to work with huge amount of data, which will enforce some amount of limitations on the system. And that is the reason why we go for a technique called as compression technique, and it is very very important. So data compression, perhaps the most important enabling technology that makes modern multimedia system possible. Exactly, that is what I was talking about, because multimedia system, when we talk about the modern multimedia system that we talk about, it will be combination of all different sorts of medias, and because of which huge piles of data will be available. So without compression we cannot work in the multimedia application environment. The lossless data compression. So as I told, there will be two bits in the syllabus, so there will be two types. Like whenever we say algorithm, or whenever we say the compression is achieved, then there are two different kinds of algorithm through which it can be achieved. That is, one is the lossless data compression algorithm, and then second one is the lossy data compression, and there also there are few algorithms. So let us see one by one what do we understand by lossless data compression and lossy data compression. Now lossless data compression, that is involving no distortions of original signal once it is decompressed or reconstituted. So much data exists in achieves so much data exists in Achieve and elsewhere, that is has that it has become critical to compress this information. Lossless compression is one way to proceed. Now, here the need of compression is been stated that as there will be huge amount of data, the compression is must, but there are several applications where we cannot compromise with the quality of information or the quality of data that we have. Let us consider the case of, say for example, the medical applications. So in medical applications, whenever certain patients data related to, say for example, there are certain scans that doctors generally carry out, and those scans images are very very important images which contain huge amount of information. So if we talk about size of that particular information, and then if we thought to compress it, then we cannot afford to lose the information due to the compression. So there doctors rather prefer not to go for any kind of compression, because the data is very very precious and we cannot afford to lose it. And in certain situation like this, where the user cannot lose the information, there we prefer to go ahead with the lossless data compression, where it is clearly stated that whenever you apply the compression, then you work on that particular data. It may happen that you can transmit this particular data to the somewhere else, and then when you try to retrieve the original data after the decompression is applied, then there should not be any kind of change between the original data retrieved. So the original data should remain as it is. So it has to be reconstituted as it is, and if that happen, that is nothing but the lossless data compression. Now, as I stated, it is very very critical applications only this kind of lossless data compression is used, like the medical images or nation security related data, where with the thought of compression, we cannot compromise with the original information. So without any kind of loss, if we could compress the data, if we could after decompression, if we could retrieve the data same as the original one, then that kind of compression is called as the lossless data compression. Then the output of the encoder codes or code word, the intermediate medium, would either be data storage or a communication computer network. If the compression and decompression processes induced no information loss, the compression scheme is lossless, otherwise it is lossy. So this is what I have told you, like whenever we for any kind of application, any kind of storage, any kind of transmission through network, so whatever we do with that data after compression, once we go for decompression, the original information should be retrieved without any kind of changes, and then it is an lossless compression, otherwise it is a lossy compression. Now how do we go ahead with the lossless compression? Or if we see the block diagram of it, we'll have the input data. Now this is the input data we have here. Then we have an encoder where we actually go for the compression. Then there may be a storage, or the data may be passed from one system to the another system. So it could be a storage or a network where the data travel or data gets stored. And then when we go for the decoder, where we go for decompression, the output data will be there. And as an lossless algorithm is concerned, or lossless compression is concerned, the input data has to be same as that of the output data. So let us see what it has to say. That suppose we decide to spend our saving on a whole body MRI scan looking for a trouble, then we certainly want this costly medical information to remain pristine. with no loss of information. This example of volume data forms a simply huge data set, but we cannot afford to lose any of it. So we would best use lossless compression. WinZip, for example, is an obvious tool, ubiquitous tool that is uses the lossless compression. So it is very clearly stated along with the example which we normally used in day-to-day life. That is nothing but our the WinZip tool, where what you do, like if you have certain piles of data available for, let us say you start writing your project reports, then you have several Word files, several PDF files, several images along with that particular folder. And then if you need to transfer this particular information over a network, so generally while attaching this information to a mail, what you do generally is you tends to go for using the WinZip application, where you put all this information into a folder and then you apply the zip. So there obviously there is no very huge amount of change in the size of your information. Obviously there will be some compression, obviously there will be some kind of compression that will be applied, say 80%, say 70% compression, that if your information size is say 100 MB, just an example I'm talking about, say, or take 10 MB. If your information size is 10 MB, then once you go for applying the compression through WinZip, it could come around 8 MB or 9 MB. But that is 10 to 20% of compression that it could have applied. But once you transfer this particular information, once you send this over a mail, and at the other end of the network, once you open this particular data and go for a reverse process, when you unzip whatever the information that you have zipped, then you get the exact original information without any kind of alteration, without any kind of loss of information. And that is what I was talking about. That is what the lossless compression algorithm does. If the total number of bits required to represent the data before compression is B0, and then the total number of bits required to represent the data after compression is B1, then we define the compression ratio as B0, that is the original information before compression, divided by the information after compression. So B0 divided by B1. The higher the compression ratio, better is the lossless compression scheme, as long as it is computationally feasible. So maximum or majority of the time what happen is, generally we don't get very huge amount of compression ratios, because we in this lossless compression we cannot take any kind of risk with the data loss. So that is the reason why we don't normally get very huge kind of compressions applied. Or in exactly in contradictory way, if you take few examples of certain compression for images, so there you can easily found the difference. Like a 3 MB image, if you want to compress, and then you use several other tools rather than WinZip, and which are readily available on internet also. Or forget about image, even if you take certain example directly applied on videos as well. Like if you capture certain video with an HD TV camera, and if your phone memory doesn't allow you to watch that because of the size issue, then you compress it even at variety of the level that you want to, and even it can be transferred into a 3GP format as well, with almost 1.3 megapixel of the information resolution. And there you could have easily seen the compression ratio is almost 80 to 90%, which is in case of lossless it's hardly 10 to 5 to 10% or 10 to 20% max. But in case of the lossy algorithm, you can achieve huge amount of compression ratios, but obviously with the cost of loss of information as well. There the resolution will get hamper, there the quality of that particular video will get hamper. So if you are okay with that, but the similar amount of information will be passed by the same video which was passing earlierly. So in certain situation where size is the major concern, we go for the lossy compression, and in certain situation where information is the major concern, then we go for the lossless compression. So here there are few types of the lossless compression algorithms. Out of that, first one is the run length coding. Now what exactly run length coding does is it look for the repetitive occurrence of the data, and then it try to find out the length, and then it apply the coding. Now if you get confused with this, let us take certain example by which it will be very easy for you to understand. So let us consider a simple example of 1-bit binary image, or say bi-level image. Now bi-level image we have seen, that is nothing but 1-bit gray level images, where whatever the pixel information are there, or whatever the picture information is there, that will be either the image size, or whatever the image information of every pixel will be either that pixel will be black or the pixel will be white. So we have seen this already in chapter number 5 with let me remind this 1-bit the gray image. In this type of image we have seen that even I recall the example of the girl looking at front with the hat, the Lena image, which is very popular on the MATLAB. So on that particular bi-level image, or 1-bit gray level image, the pixel value, the pixel through which the image forms, the pixel value will be either black or it would be white. So let us take certain example of certain patch of that particular image. So it is very much possible that continuously there may be say 8 to 10 or 20 30 continuous white dot followed by few other black dots. So continuously the repetitive occurrence of that data may occur. So instead of transmitting the information, or instead of instead of coding the information of that particular pixel, if we can work on length of the repetitive occurrence, then obviously we can save lot of data. Like for example, if 5 ones are there, obviously what we are going to transmit is the 5 level 1 and 1 information that we will be passing. But if 5 continuous ones are there, and if we decided to forward only the length of like how many ones are there, and that way if we go for coding, that way if we have done the coding, that way we have worked on the encoder, then we can achieve certain level of compression. Say let me just give a simple example. If instead of denoting 5 ones by 1 1 1 1 1, if we could denote like 101, which indicates 101 is a 5. This is just an example. So here we can definitely if we go for applying a coding scheme where we have decided that whatever we have started is a 1 definitely. So in that particular case 5101, which indicates 5, which clearly states that there will be 5 ones. That way we can design the encoder as well as decoder to understand, and that way we can see we can save huge amount of space. Like that example was only for 5 ones. If say for example that example was say for 100 ones in continuous, so instead of transmitting all 100 bits of information, we could have saved that with very little amount of information that we can transmit or we can encode. So that is how the run length coding works. So let us try to understand it in detail. So instead of assuming a memoryless source, run length coding exploits the memory present in the information source. That means like in case of lossy comparisons, what generally we assume that the source does not have any kind of or does not have any kind of memory, or it does not have huge amount of memory where this all information can be stored. So rather what we assume in case of lossless information, that the source will be having ample amount of memory, and then use that for encoding and decoding for the information. The basic idea is that if information source we wish to compress has property that symbols tends to form continuous groups instead of coding each symbol in the group individually. So that is what I was talking about. Instead of coding 5 ones individually, let us try to go for code them as per its length, and that is what is been mentioned here. So the symbol that tends to form continuous groups, instead of coding each symbol the group individually in the group individually, we can code one such symbol and length of the group. Like in my earlier example, if we want to transmit 5 ones, if we could transmit a data like this, 1 followed by 101, which indicates the first one is nothing but the information for next few bits will be 1. For how many bits it will be? It will be 101, which is nothing but 5. So instead of transmitting 5 ones, if we could transmit 1 and 101, that is nothing but only 4-bit information, we would have saved 1 bit of information. And that is how the compression is achieved in case of run length coding under lossless compression algorithm. So we can code one such symbol and the length of the group. So go for coding for one symbol and then go for the transmitting the length of that particular group. As an example, consider a bilevel image. As I told, bilevel image is nothing but 1-bit black and white pixel with monotone regions, like continuously there are few whites and continuously if there are few blacks. So with such monotone regions, this information source can be efficiently coded using run length coding. In fact, since there are only 2 symbols, we do not even need to code any symbol at the start of each run. Like if there are multiple levels available for the information, say for example if you go for 8-bit gray level images, so in that case 1 bit will be having almost 255 to 256 combinations, which varies from 0 to 256. But if we go for bilevel, it will either have value 0 or it will have value 1. So we need not have to encode further because it already been encoded. It is either there are already differences in the coding, that one is 0, another is 1. There is no third option available. So here we can only start defining the length, and that way our purpose can be get solved. So in fact, since there are only 2 symbols, we do not even need to code any symbol at the start of each run. Instead, we can assume that starting run is always a particular color. It could be either black or white, and simply code the length of each run. So this way, even we need not have to go for coding if the example is of 1-bit black and white pixel or this bilevel images. But if there are other image types, then we have to go for coding. That is, we need to first code for the information, and then we need to code for the length. And this is how the run length coding works. Now the next type is variable length coding. In that we have 2 types, the Shannon-Fano algorithm and next is the Huffman coding. So I think this will be enough for today. So in tomorrow's session we will be going in details of how this variable length coding works. So thank you very much. So stay home, stay safe.